Hello and welcome. This is Sai Prasamanta from Civil Department, Dreams Polytechnic. In this lecture, I am going to discuss singly reinforced section. Of dimension B and D. Its train diagram is looking like this: linear in nature, and stress diagram is looking like this: rectangular, parabolic, okay. Here tensile force is T, here C. This lever arm is D subtract 0.42 XU, and here 0.87 Fy ratio ES plus 0.002, and at the top 0.0035. This is the block diagram of RCC. And in case of, see, this is AST. In case of singly reinforced, C will be equal to T here, 0.36 FCK B XU. We know this is XU. Okay, equal to 0.87 Fy AST. If I will find out from this, XU is equal to 0.87 Fy AST ratio 0.36 FCK B. If I will put here D, here I will put D. Clear? So this is our first equation. XU ratio D is equal to 0.87 Fy AST ratio 0.36 FCK BD. From this we will check that in the given section where is the neutral axis. This is to find out the neutral axis at which depth. Means XU is what and D is what. The proportion between these two we will check first from the equation of compressive force equal to equation of tension force. And we know XU limit ratio D for various grades of steel: 0.53, 0.48, 0.46. From the IS code book, IS 456-2000, we know these values. This is for the limiting values. And from these two, at first from the given section we will find out XU ratio D, and from the code actual permission codal provision we will find out XU limiting ratio D is what. And from these two values we will check what is the relation between XU and XU limiting. It may be less than, it may be equal to. If it is less than, this is under reinforced. If it is equal, then it is limiting state. If it is greater than, redesign we have to do. Redesign we have to do. Greater than is not allowed. Not allowed. Okay. greater than XU limit is not allowed. XU less than or equal to XU limit is allowed. So this is our first point. Then we will find the moment which equal to C into Z or T into Z. Mu equal to 0.36 FCK BXU into Z is D subtract 0.4 to XU or 0.87 FY AST into D subtract 0.42 XU. This is to find out moment. And if it is under enforced, we will use XU. If it is limiting, then we will use XU limit. And from this equation, we will find out what is the quantity of AST required, area of steel required, which completes our singly reinforced design. If it is over reinforced, we will check for. If over reinforced, we will check XU equal to XU limiting, and once again we will design, find out MU limit, then using MU limit we will find AST. For example, we are taking a section (200), 300 mm. Mu equal to 200 kilonewton meter. Then here we will find out, suppose M is 200, then Mu equal to factor of safety, partial factor of safety into the given moment, which is equal to 300 kilonewton meter. Then we will find XU ratio D equal to 0.87 FY AST ratio 0.36 FCK into BD. Suppose Fy equal to 415 Newton per mm square, FCK equal to 20 Newton per mm square. If it is given, then we will put these values. We will find out the value of XU and we will check with XU limiting value with respect to D. See, it is this value because 415 grade is given, so 0.48 into D. From this XU limit we will check that 0.48 into D is 300, nearly 150 mm. We have to check that XU should be less than or equal to XU limit here. Then only the structural element will exist. If XU is greater than XU limit, it means it is over reinforced. Applying for redesign we will not allow. for over reinforce because it will fail suddenly. So as per code, over reinforced section is not allowed. And from this we will check XU is less than or equal to XU limit. Then we will find out mu limit equal to 0.87 Fy AST into D subtract 0.42 XU. From this we will put the mu limit 0.87 Fy D subtract 0.42 XU and we will find out AST how much. This is our required design. Okay, thank you.